Hello everyone, welcome to my channel. So here we are going to discuss the concept and the problem based on subspaces. So if you want to check any given set is a vector subspace or not, just we are going to follow the one step formula, one step test. That what is that? If a for non-empty subset W of V, suppose V of F is a vector space and W is a subset of V, and this W is said to be a vector space if for that we have to check only one condition, that is we have to take, first of all we have to take two elements of your given subset. You have to take the given you have to take two elements from the W, okay, and we have to take two scalars from the field. We have to take two elements W1 and W2 of the set W, and we have to take the two element or two scalar quantity from your field. Then we have to check whether this condition, the alpha into W1 plus beta into W2 is also the element of W or not. Just we have to check that alpha into W1 scalar quantity into vector quantity, the W1 plus beta into W2 is also this is also the element of your W or not. Let's see the example. So V3 over R. V3 over R is nothing but collection of order triplet. Okay, V3 over R is a vector space over the R which contain the order triplet, that is the A, B and C. Okay, and where the A, B, C all are real number. Now the field F is the field is your set of real numbers. This is V3 over R is a vector space over R. Now they have given you one set, that is W. In this W contain the order triplet. So it means it is a subset of your W is a subset of your V3, right? Because it also contains the order pair, order triplet, and V3 also contains the order triplet. But condition is that in W we have to collect only those order triplet which satisfy this condition. What is that condition? A plus B plus C must be equal to 0, where A is also real number, B is also real number and C is also real number. In W, here we have to collect only those order triplet which is going to satisfy this condition. Okay, so then we have to check whether it is a subspace of, it is a vector subspace of V or not. Okay, so first thing we have to check whether, if you want to check any given vector, if any given set is a vector subspace or not, first thing is we have to check whether the identity element is present or not. Okay, with respect to addition, so in the R3 over R, V3 over R, the order identity element is 0 0 0. Okay, if this is present or not, we have to check in the W. Okay, so if you want to see that the order triplet 0 0 0 is present in W, it must satisfy your given condition. What is given condition? A plus B plus C. 0 is also real number. Now we are taking the A value has a 0, B value is also 0 and C value is also 0. If we add these value A plus B plus C, again you are getting the 0, right? So the condition, this condition is satisfied. That's why we can say that the W contain this element 0 0. It means since we can say that 0 0 0 is belongs to W, because 0 is also real number and it is satisfying this condition. So we can see that this W contains the identity. So your W is non-empty. And then we have to apply the one step test. What is one step test? For that, I have to take the two elements from the W. One step test say that we have to take the two elements from the W. So we have to take the elements from the W. In this W, we have a W contain which type of element? W contain the order triplet which is satisfying this condition. If I take two elements, W1 equal to A1, B1, C1. Okay, and then W2 A2, B2, C2. These both are the element of W. If both are the element of W, so it must satisfy this condition. What is that condition? A plus B plus C. If A, B, C is the element of W, it satisfies the condition that is A plus B plus C equal to 0. Similarly, W1 which contain A1, B1, C1 is also the element of W. So this condition must be satisfied, that is A1 plus B1 plus C1 must be equal to 0. Similarly, the A2, B2, C2 is also the element of W. So it must satisfy this condition, that is A2 plus B2 plus C2 must be equal to 0. Okay. Now we want to show what we want to show. We want to show that alpha into W1 plus beta into W. Alpha and beta are the scalar quantity. We want to check that alpha into beta 1 plus alpha into W1 plus beta into W2 is also the element of your W. For that, I have to consider alpha into W1 plus beta into W2. Alpha, keep alpha as it is, substitute the value of W1. What is the value of W1? A1, B1, order triplet, A1, A1, B1, C1, and then beta into W2. So keep it beta as it is, then substitute the value of W2. The value of W2 is A2, B2, C2. Okay, then multiply this alpha throughout this bracket and multiply beta throughout this bracket. So what you are going to get? Alpha A1, alpha B1, alpha C1 plus beta A2, beta W2, beta B2, beta C2. Now here we also have an order triplet. Here also we have an order triplet. Now add these order triplet. How we are going to add the order triplet? Just by adding the corresponding elements. So by adding the corresponding element, you are going to get alpha A1 plus beta A2, alpha B1, just you have to add these two elements, alpha B1 plus beta B2, then alpha C1 beta C2. Now the first thing is that what in here also we got the order triplet. Now whether we have to check whether this order triplet is a real number or not. The first thing, A1 is also real number. We know that A1 is real number, alpha is also real number. Multiplication of two real number is again a real number. So alpha into A1 is also real number, plus beta is also real number, A2 is also real number. So if you do the multiplication, again it will be a real number. So if you do the addition of two real number, alpha A1 is also real number, beta A2 is also real number. If you addition of two real number is again a real number. So this is also real number, this is also real number, and this is also a real number. Okay, so all are the element of your order triplet, all are real number. Now next we have to check that whether this, if you do the addition of all this real number, this order triplet, whether it is 0 or not. So consider, just add these order triplet, that is alpha A1 plus beta A2 plus alpha B1 plus beta B2 plus alpha C1 plus beta C2. Now take the alpha terms on one side, take the alpha terms and then take the alpha beta terms. It will now take out it will become alpha A1 plus alpha B1 plus alpha C1, then beta A2 plus beta B2 plus beta C. Now take out the alpha common. If you take out the alpha common, you are going to get A1 plus B1 plus C1 plus beta A2 plus B2 plus, now take out the common beta common, it will become A2 plus B2 plus C2. And what is the value of A1 plus B1 plus C1 by this equation? We know that the value of your alpha 1 plus beta 1, alpha 1 plus B1 plus C1 is 0. Substitute that value. Similarly, we know the value of your A2 plus B2 plus C2. Its value is also 0. So what you are going to get? Alpha of 0 plus beta of 0. Alpha into 0 is 0. Beta into 0 is also 0. Addition of 0 plus 0 is 0. So here we got the value of your, value of this is 0. If this is 0, so what we can see? The condition of your vector subspace is satisfied. So we can see that the alpha W1 plus beta W2 belongs to W. So that's why it is a vector subspace. Okay, this is a one-step rule. Here we have to check